We'll get going with the last two problems here. We have number 33. Basically, we have this rate function, and it says for A, it says for what values of y is the rate non-negative. So you look at this function and you say, well, when could this whole value be negative? Well, if a was less than y, then a minus y would be a negative number. So we need a to be greater than y. And if a is greater than y, then a minus y is a positive number. Okay? And that would mean that a positive times that ky, which will also be positive, because remember what these things represent. Y is grams, and we can't have negative grams. So y has to be a positive number. So rate is non-negative for this symbol here is for all, upside down a is for all y such that a is greater than or equal to y. Because this says non-negative, it doesn't say positive. So it could be a 0 too. So if a equaled y, then this would all go to 0, and that's okay because that's non-negative. And then B, it asks for what values of y is the rate of maximum. Again, we would just take the derivative of y, or we could see, for what values of y make this thing the biggest. And I think as y gets really big, this thing continues to get really big. So just go ahead and either graph the function or take the derivative with respect to y, like pretending y is the x or whatever. And that should do it for you. So last problem coming up here, we have number 35. Number 35, we have kind of a problem similar to one of the ones on 4.1, where we had where I think it was u and v. Here we have a and b. So again, we just take the derivative, pretending a and b are just other numbers, like they're a 1 and a 2 or whatever. So then we take the derivative and then set equal to 0, and that's what I'm doing right here. Just without you seeing, I add the 3b to the, I guess, over r to the 4th to the other side. So this is me just setting it equal to 0 and then adding this over. And then I do all that extra work in blue. And then it says basically, what values of r minimizes the force between the atoms. So we want to find the minimum. Okay, so we found a critical point here, and now we can plug that into the function to see what value that gives us, or we can just kind of say, well, what values would make r, the smallest, and kind of mess around with a few values and plug those into the function and see what we get. Alright, so that ends 4.2. Alright, and yeah, let me know if you have any questions at all, because I know this stuff can get kind of confusing, looking at the different graphs and all the different slope graphs and all that stuff. So let me know if you need any other help. Alrighty.